Alright friends, well now that we've got the database done for now and the initial architecture talked about, let's actually jump ahead into some code implementation. So I need to go ahead and start my project off. So we'll run npm init. I'm going to go ahead and install TypeScript because I'm not doing a project of what's going to end up being a decently sized backend without implementing TypeScript. So we'll run tsc init, and then we are good to go with our implementation. So yes, I trust myself. So I'm going to go ahead and get started actually creating our types. So we'll go ahead and create that index there. And I'm going to hop back over to our database here just so I can re-reference this. I know I said we're over-engineering it. I'm still trying to keep it like fairly minimal. But ID name email is verified. What I'll do here is just some copy-paste Rooney. And use that to kind of derive everything. So ID number, let's see, name string, email string is verified. So we could make this Boolean because all we're going to be doing is like, you know, a truthiness check on that property, and it's getting stored as a 0 or 1 under the hood in the database. The MySQL library might actually translate that over into a Boolean, but I mean it doesn't really matter because we're evaluating one truthy value and one falsy value for true and 1, and then 0 and false respectively. So like you can do either or. I might actually do a little type here saying no, it's explicitly only going to be 0 or 1. I don't know. Nitpicky. Alright, we've got our user interface described. So let's go to our lists. Actually, let's do list item first. I guess we can do list. ID, user ID. Okay. So the list is also going to have a numeric ID. Oh, whoa, 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 whoa. Hold on, Andrew. I'm doing UUID for this project. I glazed over that mentally for a few seconds, but no, we are doing UUIDs for this project. So I feel like that was kind of like an episode of Blue's Clues going on here. I'm sure somebody, you know, watching this video was like, Andrew, you idiot, it's a string, not a number. And we'll pretend I heard you guys from the past and corrected everything retroactively. So good work, audience. And instead of making the user ID string here, it's a little weird quirk of mine, but one thing that I like to do to demonstrate foreign key relationships when I'm, you know, making interfaces describing my tables is I don't like to just mimic the type. Like I don't like to say, oh, if user ID is a string, this should be a string here. Instead, what I want to do is actually reference that interface's specific property. And that gives us kind of a single source of truth. So right now, a list user ID is a string, but if I were to update my IDs to be, you know, integers or numbers, list.userid now derives that from the user ID property. So we just have kind of a better single source of truth, you know, with this in action. So list items, ID, name, list ID, ID string, name string, and then list ID is going to be not a string, but instead list interface ID property. And then finally, let's see, user lists, I think is what I call the table. Yep. So user lists, user underscore ID, that's going to be the users column again, or users interface ID property. And we'll do the same exact thing for list ID. So not only do we get like a good single source of truth functionality out of this, but it's also a really nice just visual indicator that I've probably got a foreign key in the database. So that's kind of what I also enjoy as just like a secondary benefit. But now that we've got that defined, let's go ahead and get started writing our database queries for this app. So, I typically like to approach stuff from like the database level up. So I like to have a good backend foundation first before I create anything else. And so let's go ahead and get started with that. So I'm pulling in MySQL, my types, and .env. Is this my config folder? Yes, it is. Okay. So I'll go ahead and import .env. I'll run .env.config. Get everything loaded up. I need to go ahead and create my environment variable file. So .env there. I need to go ahead and run git init. Then create my git ignore. And then add my env to the git ignore. All right. And I haven't created my environment variable user or values yet, but I typically use the same exact variable names for those, so db user, db pass, nothing really special about that. Alright, and we're also going to do some copy paste to Rooney to kind of reverse engineer all of this. So copy this, paste in it here in the .env, then every comma, control D, all of that, then hold on, control, shift home, delete. And for this, for local development, just root localhost, just getting that quickly added up there. The actual database name itself is overengineered grocery list, which is a mouthful, but that's what I created it as, so that's what we're rolling with. Alright, so we've got our environment variables set up, we've got our types defined. Let's go ahead and export my database config out. Then I'll create a database folder here, or DB, why not? We can be cool, we can use shortcut variable names. Alright, we'll import MySQL, we'll import my database config, or MySQL config, I forgot what I had named it already. And then we'll go ahead and define a query function here that allows us to dynamically requery our database, wrap it in a promise. We can keep everything nice and async. We can also give it a generic to help us with some nice IntelliSense, just establishing the return type from the get-go. So first I need to make a pool using our credentials. And the generic we're passing in, we'll give it a default value of the MySQL OK packet. We really only need to provide the generic when we're running select or if we're doing something like a stored procedure, because otherwise it's going to be the OK packet for any insert, update, delete by itself, which is going to be like a little more than half of our queries. So just by doing this generic with a default value, we don't have to type half the queries, you know, just good IntelliSense even with a low-level driver, so why not? Alright, so we'll have this function return a promise, and that promise will give the generic, so boom, we've got some good IntelliSense on that. Let's see. Alright, then we need to execute pull.query. So we need to accept a couple arguments. One is the SQL string that we will always have to pass in because we always have to be running some kind of query. And two, an optional array of values. So we can go through the safe sanitization process provided by the library. SQL string, values is going to be an unknown array as its type, and we'll give this a default value of an empty array. Depending on what version of the library is, you can have values be undefined, and it's totally fine. But if you're trying to do something manually, like mysql.format, in order to see the formatted SQL for some debugging purposes, that actually will require an array, even if it's an empty one nevertheless. So if you have it marked as optional, it's very unhappy with receiving undefined. So if you just give it a default value of an empty array, you have effectively made it optional, but it also does satisfy not only just the regular query function, but the MySQL format function or any other accessory functions that might deal with the sanitization process. So that's why I give it a default value of an empty array instead of just an empty string. And then we have our callback here. If there's the error, we'll go ahead and reject with it. Otherwise, we'll go ahead and resolve with the data. So now we have a very nice and reusable query function wrapping around our pull.query. And we can start writing individual query files here. So I want to go ahead and start, let's see, making list items, because those are going to be the nice and easy peasy things. So what I want to do is, the way I'm envisioning stuff on the client side, I'm going to be using a library like React Select, so that way I can, have it pre-populate and fill out a lot of pre-existing tags. So that way I'm not retyping the same strings over and over. I might, let's see. Yeah, so I mean, at least this gives us like auto completion on items that we've already used before in the past. So that means the longer I use this app, the more effective it's going to be. That gave me a thought. I could maybe do a use count. So like a more utilized item, I could rank higher, and I could sort by that. So that way when you're, typing stuff out, autocomplete gives you the most relevant one. But that might be something I would want to do as a feature for an individual list. So I would need another really weird many-to-many relationship for like list item utilization. Yeah, we'll see about that. Otherwise, I could just put like a simple count on the list items table, and like what's popular amongst the most users would be seated up the highest, and that would be the super easy way of implementing it. Okay, I'm just gonna tuck this nugget aside. Sorry, I like having these like random asides in the middle of these videos, just showing kind of the spontaneity of the development process sometimes. So I'm glad we kind of talked about that, because that is an interesting feature I might want to implement. But for now, let's go ahead and at least get kind of our base queries defined. So we're gonna have the bare bones items here. So I just want to be able to create basically a name, or hold on a sec. Now that I say that, I think I want a distinct table for just items, because this is kind of creating items but exclusive to a list. Well, with that in mind, I mean, that means that the count functionality wouldn't be all that bad either. So like for a specific list, if it's your grocery list, you're gonna get your stuff. Okay, that's actually not too bad. So yeah, I'm still kind of mentally planning that out. Okay. But list items is, you know, a table exclusive to a list for a user. So let me rename this to list items then, because for some reason I also was mentally thinking items was its own distinct table, but list items is not doing a unioning of lists and items, but instead is its own separate entity. So right, import my query from the index. See. Oh, and yeah, with everything being string IDs, that means I'm going to have to create that beforehand. So I actually need to provide all three of these. So that means that my data type, when I'm calling this query, actually needs to be all of those properties, meaning I can just give it an object and let the MySQL library use the set syntax to unpack an object's properties and values, which if you haven't utilized this before, it's extremely convenient. Instead of having to enumerate the three separate column names, these three separate placeholders for the values, providing three value arguments here, providing three value arguments here, you can instead just give it one object, and for the set syntax, it will unpack that object for you. So it's extremely convenient. So we'll have a list item described new item object here that we provide. All right, and we need to be able to delete a list item for a list. So we'll need the item ID and the list ID both. So we're not deleting, you know, peanut butter for every user. We're deleting peanut butter for a specific list. So my IntelliSense is at the moment, because I keep trying to like tab autocomplete, and I keep getting excited that list is the first thing, and I want to tab to get it to expand to list item, but it just completes that. And I could do like string for both of these, But yet again, I kind of like that single source of truth methodology here. So it does make this a lot more verbose than just saying string here. But what it does give us is the single source of truth functionality. So if I did decide to update, list item to a number for its ID, then these changes propagate everywhere throughout my application. So I don't have to manually adjust this from string to a number as long as it is aligned with list item ID. So there are benefits. It does make it a little more verbose, but I really do like just taking care of it from the beginning, and that way any migrations downstream become a lot easier. And it's especially important in this application because this app is, going who knows where. Just gonna have fun with it, see where it takes us, but alright. So we can create a list item, and then we can destroy a list item. Let's see, and we'll leave it at that for now. Let's see. For creating a list, let's go ahead and get that created. And just kind of like the create function with list items, since I am creating the ID, I really do need every single possible property available. So I'm just going to stick it all in an object when I call this create function and let the set syntax unpack everything for me. So new list, insert into lists. I think I screwed up my previous query in list items by leaving out the table name. Which I did, so insert into list items. Alright, creating the list. And I guess we can also delete one. Alright, so I think for now that's pretty okay for lists. And for list items. Now it's time to go ahead and create our users queries. So kind of the same as above. For the previous couple of files, we'll create a new user object, and virtually everything we're doing does require us to create everything ahead of time. So ID name, email is verified, username, password is verified. We could mark as optional just because the database sets it. Or we can also just have our server send 0 as the value anyway, just so we don't have to create like a new type that user extends, like a creatable user one. So right, so new user object, insert into users, and let's see. We need to get a user, either by username or email. So I want to make one query that can just dynamically grab those columns. Let's see, delete. I'll leave off that functionality for now, but all right. So I'm creating a column parameter here that can either be the string email or username, because the MySQL library does allow you to dynamically interpret a column. And those should both be strings, regardless of which one I do. So query is actually going to return a user array here. We'll say select all from users where. Now, which column am I using? Doesn't matter, because like I said, the MySQL library can dynamically interpret column names with the double question mark placeholder. So where column equals value. In the MySQL library, we're running a select. Even if it's a primary keyed field, it doesn't know that ahead of time, so it's always going to return its data in an array, even if you are just selecting an individual item. And then finally, user lists. So I need users and I need lists to be able to group all of that logic together. See, and I want to rename that type. So typically speaking, I like to have my types be singular names just because I'm describing a single object at a time. So user list, that would be a little bit better. And then for the user list, I need the list ID and then the user ID, because I create the list ahead of time. So this is us just creating that association. And let's see. So just going back to that associative typing as well. User list, has a user ID column that I know it's more verbose, but user ID is deriving that here. Let's say I use some variable pizza, just to kind of break that, visual distinction. It's a string. Why? Because it's pulling from user list at the user ID column. If we look at user list at the user ID column, it's pulling that from the user ID column. So if I change my user ID type to number, this all the way down here becomes a number. So yeah, that's why I like that associative kind of effect here. Just having everything be self-referential means at the top level you adjust one thing, and it's just a cascading effect of adjusting your code, where it needs to. So I really, really like doing it, and this is just kind of a good example why, since this is deriving a type from an interface which derives a type from another interface. Just wanted to show that kind of good transitive action. And I say that, but I can also give it an object with the two things inside of it, which still uses the same typings. It's just a little less for me to type in my function arguments here. So And that's kind of it, just at a superficial level for getting our initial query function created, and then writing these individual queries utilizing that. That give us really good IntelliSense on the data coming in and what comes out. So I think I'll call it at that. And as we keep on working on this application, I am guaranteed to need write a few more queries just for some more tailored purposes. Like, I don't have selects pulling in all of the data, so I really need like a user lists query that gets everything for, or maybe even like a list that gets everything for a user list, combining everything with list items. But yeah, okay. So I'm happy with kind of our initial structure. So yet again, this is another one of those kind of longer, boring setup ones, but we did create our repository, we did pull in .env, and we did get our database connection set up. We do have our database query function, wrapper here, giving us really good asynchronous repeatable querying functionality with some really good IntelliSense too whenever we utilize this. And we've written out kind of the base level of our queries. So it's been a little more of kind of like the boring foundational work that we have to do first, but it is work that has to be done to get the application up and running. So in the next one, we're going to be working on a little more interesting stuff, actually writing some routes so we can communicate to this backend to start getting everything actually working. So I hope you enjoyed this series thus far, and I hope you enjoy creating your own grocery list app that's over-engineered way more than it needs to be. But go ahead, like and subscribe, and drop anything in the comments if you've got suggestions on features you'd like to see me add, because you might catch me just in time before the next parts are out. So that'd be pretty fun. But let me know. Otherwise, I'll catch y'all on the next installation. See ya.